Hello, you're welcome to our lecture series on chordates. Today's lecture will be on classification of Pisces, that's the fish. Earlier, we had defined Pisces, or the word Pisces, as a conventional name that includes fish and fish-like vertebrates. And I had also explained in my previous video that Pisces belong to two superclasses, the superclass Agnathostomata and the superclass Gnathostomata. And that in the superclass Agnathostomata, or the agnathans, we have the classes Myxini and Cephalaspidomorphi. Myxini being made up of the hagfishes, while the class Cephalaspidomorphi has the lampreys. And we had discussed that earlier. And the superclass Gnathostomata consists of all jawed vertebrates that have jaws, and it has the classes Actinopterygi, Sarcopterygi, Chondrichthyes among the Pisces, then other vertebrates like the amphibians, reptiles, birds, and mammals. So today's lecture will be on the superclass Agnathostomata and among the Pisces, the superclass Agnathostomata. As explained earlier, the superclass Agnathostomata consists of all vertebrates that have mouth with jaws. The Pisces in the classes Chondrichthyes or Salaci, which consists of the sharks, the rays, the skates, the chimeras, and others. And it also has the superclass Agnathostomata also has the class ACTINOPTERYGII, which has all the ray-finned fishes, like the barracuda, the croaker, and others that we know around here in Nigeria. And the superclass Sarcopterygi has the lobe-finned fishes, like the African lungfish. And all of these belong to the superclass Agnathostomata, as explained. So in the superclass Agnathostomata, we have the class Chondrichthyes, the class Actinopterygi, and the class Sarcopterygi among the Pisces. Then others that are not Pisces include the amphibians, reptiles, birds, and mammals. Now I want to look at the first class in the superclass Agnathostomata, and that's the class Chondrichthyes. The class Chondrichthyes basically consists of Pisces that are characterized by the possession of cartilaginous skeleton. The class Chondrichthyes is characterized by Pisces that are characterized by the possession of cartilaginous skeleton. Their endoskeleton, as well as their external skeleton, is made up of cartilage. It's made up of cartilage rather than bone. These organisms lack true bones and swim bladder. Their fertilization is internal, unlike the other Pisces that carry out external fertilization, where the male and the female swim together, and while spawning, the female releases these eggs into the water, while the male also releases sperm simultaneously, which smears or fertilizes the eggs externally. But for these Chondrichthyes, the sharks, rays, and skates, fertilization takes place internally. And these organisms in the class Chondrichthyes possess 5 to 7 fully developed gill clefts, opening separately to the exterior. Most sharks and all rays have an opening behind each eye called the spiracle, which is modified first gill cleft. It's a modified first gill split. So gill cleft. So it's a kind of gill cleft, but it's called the spiracle. It's modified. Now I want to look at the fact that these chondrichthyes have a dorsal fin and the anal fins and the spines that are rigid and that are not erectile. The dorsal fin or fins and fin spines are rigid and not erectile. These fins in the classes SUBCLASS and ACTINOPTERYGII, they are actually erectile. They can fold them and they can erect them. They can stand and fold them, can erect and fold them. But for the chondrichthyes, the fins are actually rigid, constantly being open, just as it is in this shark. These pectoral fins, the dorsal fins, the anal fins, the caudal fins, they are all rigid, not foldable, not foldable and not erectile. The scales, if present, are structurally minute teeth called dermal denticles, each consisting of a hollow cone of dentine surrounding the pulp cavity and covered externally by a layer of hard enamel-like substances called vitrodentine. So if scales are present, they are usually very small. They have very small, minute teeth called dermal denticles, very small. Okay, their scales are usually very small compared to the SUBCLASS and ACTINOPTERYGII. The scales covering the skin do not grow throughout life as they do in bony fishes, but have a limited size. New scales form between existing ones as the body grows. Their scales do not grow throughout lifetime. That's in contrast with the SUBCLASS, the lobe-finned fishes, and the ACTINOPTERYGII, which are known for having large scales, and the scales have annual rings, and those rings can be used to know the age of a fish. They grow throughout lifetime, but in the sharks, rays, and skates, those in the class Chondrichthyes, the scales do not grow continuously. They do not grow throughout the lifetime as it is in bony fishes. Now I want to look at the distribution and abundance of these organisms. The majority of sharks and rays are marine fishes. Most of them are found in the sea. Most of the sharks and rays are found in the sea. They are marine fishes, but some of them are found in the estuary. Some of them are found in the estuary. And what's an estuary? Basically, an estuary is a tidally influenced ecological system where the river opens to the sea and where fresh water is replaced by a salty water, or where fresh water mixes with salt water. Some of them can travel far up into the rivers, and a few are reported to be permanent residents of the fresh water. Some sharks go beyond the estuaries into the rivers, into the fresh water. Some are known to be permanent residents in the fresh water as reported. Now I want to look at other features of the chondrichthyes, one of which is, we want to look at the classification of the chondrichthyes. The class Chondrichthyes has two extant subclasses, and the subclasses are the subclass ELASMOBRANCHI and the subclass HOLOCEPHALI. The subclass ELASMOBRANCHI and the subclass HOLOCEPHALI. I want to look at the subclass ELASMOBRANCHI, which consists of the sharks and the rays. The sharks and rays have a cartilaginous skeleton. The only bony component is found in the teeth and placoid scales. The ELASMOBRANCHs, or those in the subclass ELASMOBRANCHI, the sharks and rays, possess 5 to 7 pairs of gill clefts not covered by a fold of skin, opening separately to the exterior. So one very important characteristic of the elasmobranch, the sharks and the rays, is that they possess 5 to 7 pairs of gill cleaveds. They have 5 to 7 pairs of gill cleaveds. The male elasmobranchs have structures called claspers, which serve as intromittent organs. They are used for copulation. They are the sex organs, like the penis in other vertebrates. In this case now, the copulatory organ, instead of being called the penis, it's called the claspers. It's found around the posterior end, close to the anus. They are used for copulation, for sexual intercourse. Elasmobranchs consist of the sharks and the rays. They have exposed gill slits, typically 5 pairs and 1 pair of spiracles. They have 1 pair of spiracles. Now here are figures of, this is the great white shark that was caught in the beach of the Atlantic Ocean around Akassa in Brass local government area of Nigeria, Bayelsa State. Now, this is also one that was caught there. These are typical examples of sharks that are found in Nigeria. Now, this is the hammerhead shark, also caught in the Atlantic Ocean around the beach, around Akassa in Brass local government area of Bayelsa State, Nigeria. The next class we want to look at, the next subclass in the class Chondrichthyes we want to look at is the subclass Holocephali. Holocephalites are the chimeras. Typically they are commonly called the rat fishes. They are represented by the chimera. They differ from elasmobranchs in 1, an operculum that covers the gill slits, and the teeth are replaced by bony plates. Unlike the elasmobranchi, the sharks and rays that have gill slits that are not covered by operculum, the gill slits of the rat fishes, those in the subclass Holocephali, are covered by an operculum. The chimeras have only 1 external gill opening. They have only 1 external gill opening through the operculum. Chimeras are tropical fishes with large pelvic and large pectoral and pelvic fins. They are tapered fishes with large pectoral and pelvic fins. And they have large eyes, unlike the sharks that have eyes that are not very large compared to their body size. And they also possess 2 dorsal fins. The first is preceded by a sharp spine. Just as it is here, they have 2 dorsal fins, this and this. Then they have very large eyes. Okay, and their gills are covered by operculum, just like the teleus or the ACTINOPTERYGII. They have slender tails, from which the name ratfish, applied to some, has been derived. So they have very slender tail, and in the outlook, they look like a rat, just as being displayed on this slide. This is the ratfish. In the adult, the skin on each side of the head is smooth and lacks scales. It lacks scales. The teeth consist of 6 pairs of grinding plates. The dorsal fin and the spine are erectile. The dorsal fin and the spine are erectile. They can be folded and also erected. So we have looked at 2 very important features. The skin on each side of the head is smooth and lacks scales. In this elasmobranch, the skin is just very smooth. And the teeth consist of 5 pairs of grinding plates, and the dorsal and The dorsal fin and the spine are erectile. The dorsal fin and the spine are erectile, compared to the elasmobranchs that have non-erectile fins. Okay, the fins are permanently just straight, not being bent and erected. Okay, but these ones have dorsal fins that can be bent and then erected. That distinguishes the elasmobranchs from the holocephali. Like male sharks and rays, male chimeras have claspers that serve to transfer sperm to the female. But in addition, they have an erectile clasping device, the tentaculum, in front of each pelvic fin. Most species have another such organ on top of the head. So they have claspers, something like a penis for sexual intercourse that's used to transfer sperm to the female. But in addition to the claspers, they also have an erectile clasping device, the tentaculum. The tentaculum is in front of the pelvic fin. It's usually in front of the pelvic fin. And most species have another organ on top of the head that's also used for population. Now, this is a picture of the spotted ratfish. This is the spotted ratfish. Morphologically, the head has the appearance of a rat and has a slim tail like that of a rat. If you want to compare it with the ACTINOPTERYGII, the ray-finned fishes, it looks like the silver catfish in appearance. It looks like the silver catfish. Now I want to look at a great group that consists of two classes, the ACTINOPTERYGII and the SUBCLASS. And that group is called the Ostecthies. The Ostecthies are ray-finned fishes. They include both ancient and modern bony fishes. The Ostecthies can be divided into the classes ACTINOPTERYGII and SUBCLASS. It consists of the classes ACTINOPTERYGII and SUBCLASS. They are bony fishes that possess bone in their endoskeleton rather than cartilage. The group is named for their bony skeletons, although that is not true for all. They have membranous fins supported by fin rays. They have an operculum, and they also have scales. Now, these are very important features. They have membranous fins supported by bony rays. Okay, bony rays. That's different from the elasmobranchs in the class CHONDRICHTHYES that have cartilaginous fin rays. But in the Ostecthies that consist of the ACTINOPTERYGII and SUBCLASS, the fin rays, the fins are supported by bony rays. They have an operculum, a covering of the gills, the structure that's used for respiration, and they have scales. Now I want to look at the class SUBCLASS, which contains the ray-finned fishes. This class is the most diverse group of vertebrates. They possess swim bladders and bony endoskeletons. They are the most diverse. Most fishes we commonly see in our rivers, oceans, and lakes are basically members of this class. They are the ray-finned fishes. And one very distinctive feature of this group is that they possess swim bladders and bony endoskeleton. They have swim bladders. Swim bladders are structures that contain air inside of the fish, and it helps the fish to be buoyant. It helps the fish to float in water, to be able to swim with ease inside the water, most especially in fishes that are pelagic, that are also always swimming on the surface of the water. They have swim bladder, okay, and they have bony endoskeleton. Their paired fins are supported by bony rays. The paired fins, like the pectoral fin and the pelvic fin, are supported by bony rays. The class ACTINOPTERYGII, which are bony fishes, consists of 3 subclasses. These subclasses include the subclasses Teleostei, the subclass CHONDRICHTHYES, and the subclass NEOPTERYGII. The class ACTINOPTERYGII has 3 subclasses, and these 3 subclasses are subclass Teleostei, subclass CHONDROSTEI, and subclass NEOPTERYGII. Now I want to look at the first subclass, which is the subclass Teleostei, okay, or they are also called the teleosts. The subclass Teleostei consists of a large and extremely diverse group of ray-finned fishes. Along with the chondrichthyes and holocephalus, they are of the 3 major distributions of class ACTINOPTERYGII, the most advanced of bony fishes. The teleosts include virtually all the world's important sport and commercial fishes, as well as a large number of lesser-known species. Most fishes we eat, most fishes in our restaurants, most fishes we eat in our dining tables are basically from this subclass Teleostei and the class ACTINOPTERYGII. So they are very diverse. They have a very high biodiversity. The subclass is distinguished primarily by the presence of a homocecal tail. And what's a homocecal tail? A homocecal tail is one in which the upper and lower halves are about equal, just as it is shown here in this fish, the barracuda. The upper and the lower caudal fin are all of the same length. The upper tip and the lower tip of the caudal fin are equal. Okay, the teleosts comprise some 20,000 species, about equal to all other vertebrate groups combined, with new species being discovered each year. Now, these are typical examples of the Teleostei. These are fish samples that are collected from the Non-River estuary, the River Non estuary in Nigeria. And this one was collected from the River Non around Tumbia in Nigeria. Now look at their homocecal tail, and they have erectile dorsal fins, and they have scales in their skins. And just as we have said, their endoskeleton is made up of bones and not cartilage. This next subclass is the subclass Chondrostei. The subclass Chondrostei. This is a group of osteichthyes that have few extant species, and the few extant species are represented only by the paddlefish, or the paddlefish and the sturgeons. The sturgeons and the paddlefish are the only existing species. They have an endoskeleton composed mostly of, but not exclusively of, cartilage. Their endoskeleton is composed mostly of cartilage. That's the American paddlefish, Poliodon spathula, okay, the American paddlefish. Now I want to look at the next subclass, which is the subclass NEOPTERYGII. The class NEOPTERYGII consists of the jars and ball fins. This division represents another primitive group of fishes having few extant species, the gars and dolphins. Unlike the chondrichthyes, their skeleton is mostly ossified. Their skeleton is mostly ossified, usually made up of bones. A distinct feature of this division is their scales that are ganoid. That ganoid scales are bony and diamond-shaped scales. This is a gar, and the next one I want to look at is the crocodile gar, the alligator gar. Okay, these are typical examples of the subclass NEOPTERYGII. Then we also have the bowfin, which is called the smooth dogfish. The smooth dogfish. Now, the next class we want to look at is the class SUBCLASS, which consists of the lobe-finned fishes. Lobe-finned fishes. This is a group of bony fishes having a fleshy lobe on their paired fins. They have fleshy lobes on their paired fins. They have internal layers that open externally into the oropharyngeal cavity. They have internal layers that open externally into the oropharyngeal cavity. They possess a gas-filled air sac, just as it is in some species that have a swim bladder, but these air sacs are modified into lungs in some. The lobe-finned fishes are largely extinct group of fishes. The group consists of only approximately 8 extant species. Only 8 species. Typical example is the African lungfish, Protopterus annectans. The Sarcopterygians have 2 orders, and the 2 orders are the orders Actinistia or CrossopterygiI, which consists of the coelacanths, and the order Rhipidistia, that consists of the long fishes, including the African lungfish that's displayed on this slide. I want to look at the order Actinistia or CrossopterygiI, which has the coelacanths as example of existing members of this order. Coelacanths are deep sea fishes of the family Latimerridae. The name refers to their hollow fin spines. The name coelacanth is derived from Colios, which means hollow, and acanthia, which means spine. The coelacanths are powerful predators with heavy mucilaginous bodies and highly mobile limb-like fins. Now, they are powerful predators, and they also have a heavy mucilaginous bodies. Their bodies are heavy and covered by mucor, and they have highly mobile limb-like fins. Now, these are their limb-like fins that are highly mobile. Their fins are like legs. They average 5 feet in length and weigh about 100 pounds. That's about 45 kilograms. Now, this is the picture of the coelacanth. Look at the lobe. They are feet-like, limb-like fins, highly mobile. Now, I want to now look at the next class, which is the next order, which is the order Rhipidistia, consisting of the lungfishes. Rhipidistians, or the lungfishes, are air-breathing fishes. Unlike other fishes that do not breathe air, these ones breathe air. They do not use gills, but they use lungs. So they will have to come out to breathe air and then go back to the water to breathe. They breathe atmospheric air and swim in the water. The extant species occur in rivers and lakes in Africa, South America, and Australia. The African lungfish is the African lungfish that is found in Nigeria is called Protopterus annectans. Most species grow to substantial sizes. Of the African lungfishes, The yellow marbled Ethiopian species, Protopterus eutypicus, is the largest, growing to the length of 2 meters. That's about 80 inches. This says, now look at the distinctive features of this other Rhipidistia. The slim A-like African Protopterus are the even slimmer South American Lepidosauran paradoxa have long, stingy, very mobile pectoral and pelvic fins that are in a constant state of agitation, touching and sensing surroundings. So their pelvic and pectoral fins are used as tactile organs, sensory organs. The tips of these fins have highly developed sense of touch. The fish are almost blind with respect to perception of form and movement. Pressure and turbulence are sensed by means of sensory structures called lateral lines. The Australian lungfish has entirely different appearance. It is more compactly built and has large overlapping scales. The pectoral and pelvic fins are much broader, unlike that of the African lungfish. The African and South American lungfishes have paired lung sacs. In the Australian lungfish, the left lung sac atrophies. This is a picture of the African lungfish, Protopterus annectans, found in Nigeria too. Adaptations for breathing. The lungs in lungfishes are primitive like those of amphibians, but in function and both in function and structure. They are used for respiration, but they are as primitive as those of the amphibians. The name lungfish is thus well applied. These fishes have sac-shaped pneumatic organs that lie along the alimentary canal. They have sac-shaped pneumatic organs that contain air for breathing. The inner surfaces of these air-breathing organs are covered with great number of honeycomb-like cavities covered with fine blood vessels. As in terrestrial higher vertebrates, gas exchange takes place in tiny air sacs.